Hey everyone. In this video, I will give you a brief overview of the three types of mass collaboration that are discussed in the bit-by-bit book. And the first one we're going to talk about is human computation tasks. Again, this is the overview of the three different types of mass collaboration online that can basically support our research projects. And the first one, human computation, basically involves researchers combining the efforts of many people working on simple micro tasks in order to solve problems that are essentially impossible or impossibly big or too big to complete for one individual person, right? And so one of the examples that is discussed in the chapter is the Galaxy Zoo project, where it was about classifying different types of galaxies, and just due to the sheer number of galaxies and the fact that back then when this project was started, there were no machine learning classifiers that were accurate enough to do this automatically. Researchers created a game essentially where people were able to, individually classify galaxies into different sets of categories. And so by then thereby combining the work of thousands of players online, or thousands of people who participated voluntarily online, and combining those, they were able to ultimately classify a large set of galaxies that wouldn't have been able to classify only using research assistants or graduate students and things like that, right? There's another example that I'm going to talk about in a second in the political or social sciences, which is crowd coding political manifestos, which is usually done by experts, but this paper kind of showed how non-expert human coders can basically achieve the same task but at a much larger scale and a much faster and a much more efficient way, right? So in general, when we think about these human computation tasks, the key is that these are tasks that are relatively easy, but there's a large number of there's a large number of them. There's a big, they have to be kind of solved at a large scale, right? Those are often problems where where you need human involvement, human coders. Of course, the boundaries here are shifting. For example, when you look at this Galaxy Zoo example, based on that research, they actually managed to develop more accurate machine learning classifiers that ultimately now kind of are able to kind of achieve the same task. But in general, there's still a lot of tasks where we can't just easily train a computer to do the classification. So we need human intervention. We need humans to actually, for example, classify political text in this case, right? But the key is that that ultimately these problems all follow kind of a similar pattern, where you have a simple task that has to be completed many times at large scale. But you can easily split it up into small little chunks that are manageable for one person. And the idea is to basically spread that work across a large number of people, and then ultimately combine all of these classifications or ratings or whatever you might have into aggregate ratings, which ultimately can be as accurate or even more accurate than, for example, expert codings, right? But the key is that they ultimately can be combined with supervised learning, right? So we can use that labeled data that we get from human coders to train machine learning models to ultimately then, create an automatic classification based on some machine learning classifier. Okay. Um, and this is overall this is increasingly important as we move from numeric data, survey data and so on, in the social sciences to working with just large amounts of text. Or potentially images or movies or audio. So these are all data, large amounts of data that can potentially be classified for political content. But in order to classify that large amount of data and use it in our research projects, we ultimately need to kind of crowdsource the labeling process, even if it's only as a first step to then later train a machine learning model. Right? So one really great example for this is crowdsourced text analysis, reproducible and agile production of political data. I uploaded this paper on Canvas as well, and we can chat about it more in the Q&A session. But just to give you an overview, here's just a section of the abstract, which states empirical social science often relies on data that are not observed in the field but are transformed into quantitative variables by expert researchers who analyze and interpret qualitative raw sources. While generally considered the most valid way to produce data, this expert-driven process is inherently difficult to replicate or to assess on grounds of reliability. Using crowdsourcing to distribute text for reading and interpretation by massive numbers of non-experts, we generate results comparable to those using experts to read and interpret the same text, but do so far more quickly and flexibly, right? And so we'll talk a little bit more, or we can talk a little bit more about the details of this paper in the Q&A session. But essentially, what they're looking at is party manifestos and classifying party manifestos as left or left or right policies on economic and social dimensions, right? And so usually, traditionally, this has been done by experts who in the field, in a comparative context, who read through the parts of the manifestos by in a kind of sentence by sentence or abstract by abstract basis, and then coded each of those sentences according to some coding scheme, right? And so what they show, or what Benoit and co-authors are basically doing, is translating this into a crowdsourced task where people are recruited through platforms like Mechanical Turk, and rather than having experts code the political text, you essentially have or people who are paid on MTurk to kind of code the small sections after giving some instructions, right? And so, of course, individual codings by non-experts might be more there might be more random error, more measurement error potentially, but the key is that compared to the experts, there's a large number of coders doing basically overlapping codings of text. And so by averaging across a large array of coders, even if there's more kind of random error in those codings, you can get more accurate or comparatively accurate codings of these political texts, right? But the big advantage compared to the expert codings is that it's much easier to scale. And for example, in this example, the party manifesto codings, for example, if you want to add an additional dimension, or if you're interested in now recoding manifesto data, going back to include, I think the example that they use is immigration as a policy dimension, which wasn't included in the original party manifesto coding, but you can basically go back, and it would be very difficult to kind of go back manually and have expert coders go through all the old documents again. But using this method, it's fairly easy to kind of create new scalings for an additional dimension, even going back, how many years, and recode the old manifestos as well, right? So it can be better, it can be more accurate, but importantly, it's also much cheaper than expert codings, right? So this is just one example that shows that just by leveraging crowdsourcing, we can actually get a lot more efficient coded data. There's another example by Benoit and other researchers published recently where they use a similar method to code political sophistication in text that are also included on Canvas. So feel free to check that one out as well, and we can talk more about that as well in the Q&A session. Okay. All right. In the next video, I'm going to talk about open calls, yeah, I think I'll take a break. Initially, I wanted to do all three in one video, but I'll take a break here and upload the remaining as a separate video.